So we have our main functions, and I will update later in your PowerPoint that I have uploaded. We have the main functions of our fatty acids. Of our triacylglycerols, of course, we've learned that it is used for storing and transport of fatty acids. We have learned that triacylglycerols are also called the triglycerides. Now, it is the form, it is where our fatty acids are bounded to, in fats and in plant samples, okay, and also in plants and animal samples. So for triacylglycerols, it's also provide insulation in low temperature by preventing heat loss. And in plant, it provides an important energy reserves in fruits and in seeds. No? So where we can find our fatty acids in plants, you usually find that in seeds. So for example, we can peanut butter or the oils we can find from peanut butter, we always extract it from seeds or from fruits. For example, in your activity now in the laboratory, you're trying to extract your oil. It's a cold pressing process, no? But you will able to extract your oil from the pulp fruit of your coconut fruit, okay? And for vegetable or coconut oil that we use, cooking oil that we use, so there's a different process of extracting the oil. In fact, what you can see is more yellowish, no, ang oil na iyong makuha. But in the virgin coconut oil that you will obtain, I expect that you should obtain like a more or less colorless oil. Okay, so you can extract your triacylglycerols where your fatty acids are contained or bounded to from any seeds. For example, can name of any seeds now that really sa pa. There's a lot of seeds, even the corn, di ba? Sa kanang mga corn oil nato, no? It's actually the seeds kanang sa pulp niya, sa fruit niya, kanang kernel niya, no? It's where you can extract our oil. Okay, again, so we have this purpose or functions of your triglyceride, or also called your triacylglyceride. So triacylglycerol actually stores more energy than glycogen. Glycogen where what we have learned in the carbohydrates chapter, no, it also stores energy. In this case, the triacylglycerol actually store more energy than glycerin. So it's lipid versus the carbohydrate. And why is that? Because the triacylglycerol are hydrophobic. They coalesce into a compact anhydrous droplets within cells, storing an equivalent amount of energy with glycogen, but in about 1/8 of glycogen's volume. Okay, so they are hydrophobic. So you can actually have adipocytes, which can have the stored fats not in adipocytes, or you can find that in cells which store fats. And another reason for triacylglycerol storing more energy than glycogen is that it is less oxidized than the carbohydrate molecules, in which it releases more energy when they are degraded. For instance, the energy release is 9.3 kilocal per gram of fat compared to 4.1 kilocal gram of carbohydrate. So again, your source of energy can be your carbohydrates, or your source of energy can also be your lipids. Okay, so manang whichever you eat, no, yeah, you can gain a lot of energy, but you just have to be careful if you are calorie conscious, no. Triacylglycerols store more energy than glycogen. So if you want to avoid getting adipocytes on your cells, on your fatty cells, of course, you want to avoid the fatty parts of ganang mga animal fats or animal source or kanang sa plant source. no, because it stores more energy than the glycogen. So the best thing, of course, you just have to control your diet. Again, so last time we talked about the reactions of our alcohol, of our triglycerides, and one of the reactions is the hydrogenation reactions. So we can have the hydrogenation reactions, the same reaction that you have learned with your alkene, with hydrogen in the presence of catalyst. Your catalyst can be platinum, palladium, and nickel. That's what you've learned in your organic chemistry. So again, we have discussed this last time. If you want to prevent spoilage of our oils, fatty foods, no, from the liquidy part, we want to partially hydrogenate our oils and fatty acids into saturated ones, so from unsaturated to saturated one. And we have already discussed that, again, the purpose of partial hydrogenation, the overall purpose is to slower down the spoilage of our oils. And another action, of course, is the saponification of our triacylglycerides. And again, I will have to ask you, if you haven't done this kind of reaction in your organic chemistry, then we can do this kind of reaction in your laboratory. Okay, so another one kind of lipids is what we call as the wax, or the wax ester. The wax is a complex mixture of nonpolar lipids, and it is used as a protective coating on leaves, stems, and fruits of plants, and skin and fur of animals. The main constituent of waxes, you have the ester composed of long-chain fatty acids and long-chain alcohols, and they also contain hydrocarbons, alcohols, fatty acids, aldehydes, and steroids. And the same with triacylglycerols and fatty acids, they also serve as energy stores and water repellent. So where can we find the examples of this? You know, oCarbauba wax, no? Produced by the leaves of the Brazilian wax palm. It's composed mainly of the ester melissyl cerotate. You have this a long chain of hydrocarbon here, and you have the cetyl bond O, and you have a long chain again of hydrocarbon. So most of the waxy part, for example, the gabi leaves, no, it's also can see on in the morning, no, some of the leaves that you can see would have droplets of water in them, and can have the waxy part kana sa mga leaves usually, di ba, sa unang panahon they just use leaves pasinaw sa mga salog, no? So it contains mostly contain waxes. Then you also have beeswax. It's a main constituent. Is tricontyl hexadecanoate. You have this. We have the part which is a palmitic acid. You have cetyl bond O, and then for 14 plus 5, so 16 carbons here with the COO, the ester part of the palmitic acid, and then you have the tricontanol. So this is the main constituent of the beeswax. Where can you find your beeswax? Sometimes no kanang mga medyo waxy nga mga personal care products na yung makita. For example, kanang pamahid. No? Let's say, give me an example of kanang personal care products that you use nga medyo waxy. Anyone?
Petroleum, ma'am.
Petroleum is made up of kanang solids because it's a hydrocarbon, mostly made up of hydrocarbons. You don't see an ester part there or something. So aside from the petroleum came from the petroleum industry. It's a byproduct of from the fractionation of kanang fossil oils, no? So when you separate oils into, for example, gas, diesels, and so on, katong dili nila separate into the liquid part, katong mabilin sa petroleum. So manang solids, you can have that petroleum jelly. It's actually made up mostly of hydrocarbons, higher molecular weight hydrocarbons. No? So we don't see esters there. So the difference between waxes and lipids, no, you can see la COO, other functional groups, no, katong akong na-mention ka kanina. So kung hydrocarbon lang siya, hydrocarbon like the petroleum products, no, you don't see any functional groups like cetyl bond O. Okay, so that's the difference between the wax and katong petroleum jelly. Okay, so another example aside sa katong giingon nga wax, so that one is not a wax, although it's waxy one because it's solid. It is composed, petroleum jelly is composed of high molecular weight hydrocarbon. Again, it's a byproduct of the from the fractionation of your fossil oils. So you have kanang, for example, sa mga kachalis, kana bitong mga waxy, even sa mga kanay pang pahid-pahid, no, mga pangbutang sa naong nga pahid-pahid. Others are using beeswax. They're also using petroleum actually. Most of the personal care products na medyo waxy, they're using petroleum, and they would solidify that one. Some are using hydrogenated parts, partially hydrogenated kanang mga oils, no? For example, dili na example ng margarine. Sa kinala, di ba margarine is like more solid, no? More siya waxy. And you can see some personal care products also nga inana, they have partially halogenated. But there are those that's actually using beeswax, no? Some manufacturers would rather utilize beeswax over petroleum jelly. One, because beeswax is much more less expensive rather than the petroleum jelly. Kasi mahilig ang mga kana bitong pa kuan sa kana bitong when you don't feel well, instead of using kanang mga efficacy, kabantay mo, there's that kuan, creations ba to? Katong creations. Kasi nakakamit yung creations.
Rab, ma'am.
Oh, rab, yeah, that one. I don't know, basta inana nga. Palagi ito sa gi-allow sa, I think, to carry something. And you can see in the component there, it's made up of beeswax. And you can check on your personal care products and it's usually kani panggamit na kanang mga pahid-pahid, no? And they would add another component that would have, for example, anti-inflammatory or some others. But the main solvent nila or sol nila, no, that they would incorporate their other ingredients, added ingredients that would have claimed health functions or therapeutic effects rather, no? But their main carrier is kung solid, medyo solid, you have the beeswax. Sa mga tiguang-tiguang, no, kana mga pahid-pahid, di ba, mga lana-lana, of course, they're using, kung wala sila BCO, kung katong mga ganahan ng mga tiguang mag-BCO, mag-virgin coconut oil, tapulan sila, no? Kana mga lana-lana gikan sa bukid, kay sila nakita nga kahoy, for example, would have therapeutic effect, anti-inflammatory effect, and so on. Then they would just extract it using kanang mga cooking oil, no, kanang inana. Pag dili pag cooking oil lang gamit, and then it's medyo solid, no, they're using kanang beeswax. Okay, so you can just look around sa gawa sa inyong balay. You can see some plants in the morning medyo kanang kusog siya mo dili mo slip bitaw of water droplets, no. You can think that the component of the leaves may contain kanang beeswax, no, or wax, which is beeswax but waxes. So there are different types. So just this instance, for example, na siya kanang ester part and then the long chain hydrocarbonic. This one ester part and the long chain hydrocarbons. In this case, carboba wax. You can have this you have 24, 25, 26, no? 26 carbons with an ester, and then this one is 29 plus 130. This one is 28, 29, 30 with the part. No? So similar in any mga structures, usually that you can find sa mga leaves or sa mga plant sources. Or this one sa beeswax, sa honey comb nga kuan. And another one, you can also have wax extracted from spermaceti oil. As an nagikan, you have the whales, which are widely used in the manufacture of lotion. Yeah, this is the one that I was referring to, mga ointments, mga ointments, mga sagol-sagol, lotion, ointments, and polishes, no? Remember na ko kanang sa unang panahon, I don't know kung nakaabot mo no? The only kind of shoes that people are wearing kay kanang mga sino-sino nga mga shoes no for formal purposes, no? Especially if you want to attend, for example, formal gatherings. Usually the men no would want to wear polished shoes, and of course you don't want to join kind mga gatherings na pangit yung shoes. We always wanted to polish your shoes, even if our bags, no, our bags, the cars also, na remember, no? Always wanted kanang the interior of my car nga medyo polished siya, dili lang kay after washing, after cleaning, I want it to be polished. So usually they're using, manufacturers are actually adding waxes in there. And if you want it to be like liquidy, so you can also have the spermaceti oil from the whales, and can check on that, what is the structure. And again, the normal structure, if nine other functional groups other than the hydrocarbons know that it is a wax. So you have already known the structure. You have already known the structure of triacylglycerol, di ba? Na siya glycerol part. You have CH2, 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 and then the ester of CH2 where you have cetyl bond O. Like you have your triglyceride, or also called triacylglycerol. You have this bonded form of your fatty acid, C double bond O instead of C double bond OH. There is this. The carboxylic acid is bonded here to the ester, and it forms an ester. Okay, so you already know the basic structure. So other than the structure, where you don't include the glycerol here parts, H2 like this one. This already becomes your wax. So since the classification or the structure doesn't belong to the triglyceride or even the fatty acids, okay, comes along ester. And then pag wala na siyang ester, cetyl bond O, and just a long chain of hydrocarbon which is of high molecular weight, then you have already the petroleum jelly. So it doesn't belong to the class of waxes. It belongs to the doesn't belong to the lipids, but it belongs to the hydrocarbon. Okay, so there are other class of other structures of lipids. We call them complex lipids. So the triglycerides that we have discussed in the previous sections are significant components of the fat storage cells, and other kinds of lipids, we also refer them as complex lipids, are important in a different way. They constitute the main components of membranes. I think I have introduced that last time. And the complex lipid can be classified into two groups. Now there are phospholipids and the glycolipids. I have already introduced this. Now I want to discuss this again here because the slides that I was using earlier, I didn't see any classifications at all. It's the introduction. So I want to emphasize on the classifications of our lipids. So the complex lipids, we have the phospholipids again and the glycolipids. The phospholipids, no, it contains an alcohols, fatty acids, and a phosphate group. So like you have an alcohol, fatty acids, and phosphate group. So you can distinguish usually your lipids, no? Pag naa siya fatty acids, kung dili mo makita fatty acids, ma-esterify ang fatty acids, and instead in the structure you can see esters, like in the earlier examples, like in the case of triglycerides or katong wax nga akong dimension, no? The fatty acids has been esterified already. No? So you have the fatty acids, alcohol, and phosphate group. Pag na phosphate group and an alcohol, then you can say that is a phospholipid. Na phosphate group, a fatty acid, and an alcohol, that's already a phospholipid. And there are two types of phospholipids. You have this glycerophospholipids, and then you have the sphingolipids. Okay, in the glycerophospholipids, from the name glycerol, no, there is glycerophospholipid, the alcohol here, excuse me, that we have mentioned is actually the glycerol. So more similar structure with the triglyceride, okay, naman siya glycerol. But here you can always check on the structure. Tanawin ninyo, there's always that phosphate group, and you have your fatty acid and alcohol. Sphingolipids is sphingosine that is part in the structure and instead of an alcohol. And of course, the last one is the glycolysis, other classification. So whenever this is a phosphate group in the structure, then you always know that it is a phospholipid. And so this is the classification that I have already shown earlier. In the phospholipids, and you have the glycolipids. You have for the phospholipids, again, you have the glycerol. Phospholipids, wherein you have your glycerol, you have your fatty acid, and then you have your phosphate group. And you can see on the structure, mura na siya parehas sa glyceride, the simple one. But instead, instead of the fatty acid and one of the glycerol moiety, you have it replaced with phosphate and another alcohol. In the sphingolipids, there's only one fatty acid you can see, but instead of a glycerol, you have the sphingosine, and then you have the phosphate group and choline. In the glycolipids, you don't see any phosphate groups. So you can see here in the phospholipid na phosphate group. Glycolipids, wala kayo makita nga phosphate group. So what you can see is a sphingosine, okay? And then instead of a fatty acid, you can see your monosaccharide, glucose or galactose, and then you have another fatty acid. So again, in the structure of glycolipids, wala kayo makita nga phosphate. And you don't see also glycerol. So makita rin mo glycerol sa phospholipid na sa glycerol phospholipids. Manigitawag siya og glycerol because there is a glycerol in the phospholipid structure. Okay, so I want you to know the difference between the simple and the complex phospholipids. Okay, so the phospholipid characteristics, it is amphipathic. It has a hydrophobic and hydrophilic domains. And you have the hydrophobic domain. When I say hydrophobic, of course, you know the term hydrophobic, right? It's composed mainly of the hydrocarbon chain of fatty acids. And the hydrophilic parts contain hydrophilic, which means it's hydro, water-loving, philic, okay, hydro, water-loving. The hydrophilic part contains the polar head group, and the polar head group contains, it's actually composed rather of phosphate and another charged polar groups. So even if you remember your fatty acids always contains two domains. Now you have the hydrophobic domain and the hydrophilic. In the fatty acids, the hydrophobic domains, again, is the hydrocarbon, but the hydrophilic domain of your fatty acid is the C double bond OOH or C double bond OO. Okay, that's the hydrophilic part. In the case of these phospholipids, the polar head contains your phosphate group. So let's have an example of our phospholipids. So here is a phospholipids, the primary, which is the primary component in the cellular membrane, is in the lipids bilayer. Can you look at, if you look at on the structure, on the structure of the phospholipids. So they are the main component of the cellular membrane, the lipids bilayer. So you can see here you have the CH2, CH2, CH2 here, and you have the ester, C double bond O, and the hydrocarbon here, C double bond and the hydrocarbon here. And you can see this one is just actually the esterified fatty acid, and this is your fatty acid. So this hydrocarbon is, you can see your non-polar tail, and you can see in the main structure of your CH2, CH2O. Okay, you have the phosphate group, and you have the this other component here. No? And you can see what I would like to emphasize here is you have the phosphate, you have the polar end, and then you have the non-polar end. So this one is also a polar end because it's an N plus. Okay. So here you have the L-glycerol 3-phosphate. It comes from this case. And what happens is that it becomes esterified here with, you have your phosphoester here with another group, and here another group using the fatty acid. So this is an example of a phospholipid. So if you look at on the cellular membranes, one of the main role of the phospholipid, of course, is in the structure, component of the cell membrane. It is used as an emulsifying agent and a surface active agent. So here, how would it act like a structural component of membrane? So here is the hydrophilic head groups of your phospholipids, and here you have your lipophilic tails or hydrophobic tails. Another term for this one, so non-polar tail, it's a term. Hydrophobic domain is composed mainly of the hydrocarbon. Okay, this is your hydrophobic or non-polar. Please don't get confused now of the term. So non-polar or hydrophobic, and there is also another term which is the gamete urea. You call this one as lipophilic. So non-polar, ako na indicate here. Okay, you have your non-polar. It's also called hydrophobic part or domain, and you also called lipophilic. Lipophilic or okay, what na siya? Pareha na siya yung kalibutan. Okay. Again, so this is the parts that you can see in the phospholipids. So you have two tails here due to the hydrophobic part. So when you look into the components of membrane, it would look like this, no? What is exposed to the water part is the hydrophilic head or the polar end. You can see here, and what is inside in the membrane is the lipophilic tails or the hydrophobic part. This is the hydrophobic part here. Okay, so when phospholipids are present in sufficient concentration, they form bimolecular layers, which is the basis of membrane. So they would form, no, like bimolecular layer, and this is actually what you can see in the cellular membranes, and this is the reason why our cell membranes, no, in the inside of the cell, you can actually have the cytoplasm, which is mainly composed of water. But outside of the cell membranes, also exposed to other environment. Of course, the main solvent in biological system is water. Okay, so water outside and water inside, and what is in between is the hydrophobic part. And somewhere in between here is where the transport of ions that would come in and out of the cell. Okay, so there is, and we didn't see, but you can see on the cellular structure that there is some channels in between that would allow the transport of, for example, ions and some molecules from the outside of the cell membrane to the inside, for instance. So the cell membrane, of course, are enclosed, would enclose all the components of the cell. For example, the cytoplasm, all the other organelles inside the cell, what you have learned in the chapter 1 of your biology. Okay, so this is the role of the phospholipid. So here is just a schematic representation of what a phospholipid is. But you know that in the phospholipid, you have this triacylglycerol here with the fatty acids, esterified fatty acids, a phosphate group, and another group. We call that one, by the way, this is the cell membrane, fluid mosaic model of the membrane. Where here you have your phospholipid, you can see ang illustration, no? Mura siya og na shape kani. The polar end, manang baga siya because of course you have the phosphate and you have the other kaning part. Okay. You have here, and then you had the hydrophobic end, and this is the first layer. Okay, and on the second layer is another phospholipid, no? The hydrophobic interaction, so that what is again on the outside or exposed to the other, like cytoplasm, for instance, or the polar end. And here, okay, here is your phospholipid layer. So it is a bilayer. When we say bilayer, there is two layer, one layer and another layer. They are interacting through the hydrophobic end. So bali-bali siya. And again, this is what I mentioned earlier. There are channels where would allow on the transport of ions and molecules in the cell. Okay. So the model is called the fluid mosaic model. Membranes allows the passage of nonpolar compounds by diffusion as these compounds are soluble in lipid membranes. So they will be transported inside into the cell by diffusion, and when they can be soluble in the lipid membranes. Okay, pag hydrophobic lang, okay, it can become soluble. And here you have the integral proteins. I think this one is where you can either have, for example, your sodium channel. No, there are channels where it will pump ions, no, because some of the ions couldn't be transported into this layer, which is hydrophobic, and ions is very polar. It's impossible. So in between this bilayer, no, you actually find some channels where transmembrane channel protein, where it can transport your polar compounds or ions. This one. So the term fluid is used because the free lateral motion in the bilayers makes membranes liquid-like. So this cellular membrane, you couldn't expect this one to be very rigid. It's actually fluid, and it's flowing depending on the interaction. There's the interaction between hydrophobic interactions and the water interaction with your membrane. So in contrast, polar compounds are transported either via specific channels through the protein regions or by a mechanism called active transport. This is what I mentioned. There are polar and ions that cannot be transported here. Okay lang pag medyo hydrophobic can be transported. It can pass through here by diffusion, but sometimes it needs to be transported by active transport. So there is this region where the channel protein, where there is channel, where it will allow on the transport of polar compounds. For any transport process, the membrane must behave like a non-rigid liquid so that the proteins can move sideways without the membrane. Okay. So we have already talked about the membrane. We have already talked, and of course you've learned, even just looking at the structure, the lipid part of the membrane serves as a barrier against any movement of ions or polar compounds into and out of the cells. Imagine if the cell don't have a barrier. You have your organelles here on the cell. For example, give me an example of organelles I mentioned. You can have your cytoplasm, your endoplasmic reticulum, you have your nucleus, of course, inside, where the genetic information are stored. So imagine if you don't have the cell membrane, this is the one that separates from the external environment to the inside of the cell. It's actually basic. The unsaturated fatty acids prevent the tight packing of the hydrogen chain, the lipid barrier, thereby providing a liquid-like character of the membrane. Of course, there's a hydrophobic interactions. That's why it looks like it will behave like a fluid substance. So there are types of phospholipids. So enough for the membranes. You know that some membranes are protected or enclosed by the phospholipids, but there are two types of phospholipids. One is the phosphoglycerides or the glycerophospholipids. It contains the glycerol, fatty acids, phosphate, and alcohol or choline you have here. So glycerophospholipids is the basic one. Again, this is structure that we have shown earlier. You have your glycerol and you have your phosphate. So instead of having your acidyl bond O, there is an ester. The ester here is not carbon ester, but phosphorate ester, phosphate ester here, before another group is being added here. And your fatty acids can also be saturated or unsaturated fatty acids. But saturated, again, you can have all straight carbon hydrogen, no double bond, but unsaturated you have the double bond. So that would matter, no, also for your cell membrane, depending on the fatty acids that would comprise your